There's a French proverb that asks, if the handle of a knife is replaced whenever it's worn out and the blade is replaced whenever it's beyond repair, well, does the knife itself last forever? Or does the knife become a new knife each time? We can ask the same question about our bodies because like this knife, bits of you are always breaking down and being thrown out, even being replaced. I mean, even right now, parts of you are dying. Some of your cells even died before you were born, and some will never come back. These are all very strange, mildly uncomfortable things to think about, but the fact is, if parts of us weren't constantly dying, we couldn't be alive. And what's even stranger than that is that a big fraction of your body is, was, and will never be alive. So how much of you is dead? How much of you has been replaced, like the knife? And has any of you always been you? Hey smart people, Joe here. I'm gonna put this away now because it's getting a little weird. Versions of that thought experiment actually go back millennia. A Greek philosopher, Plutarch, is credited with one of the first versions, and his starts with a ship. It basically goes like this. This guy named Theseus, who may or may not have actually existed, sailed his ship to Athens after defeating the Minotaur, that mythical bullman who lived in the labyrinth. To honor Theseus, the people of Athens preserved his ship for hundreds of years. Whenever part of the ship needed to be fixed, they replaced it, over and over, plank by plank, until eventually no original pieces remained. So, is it still Theseus's ship? I mean, take this stack of blocks. I can replace it brick by brick until it's a new version of itself. I mean, it looks the same, so is it? I mean, what defines the essence of the stack? Its stackiness. Is it the number or the pattern of the colors? Well, then perhaps it's the same stack. Or maybe the atoms in the blocks or the stack itself. Then you might say it's a different stack. Or maybe it's something else. In Japan, people have been doing something like this since the 7th century. This Shinto shrine gets rebuilt piece by piece. Every 20 years, there's basically a new shrine. Or is there? It aligns with Shinto beliefs around the impermanence of nature, but also this idea that the only way something can last is if it's eternally rebuilt. Some of you might say there's always been just one ship of Theseus, or one stack of blocks, or one shrine, a thing bigger than its pieces. Others might argue that when a thing or any part of it is replaced, then that thing becomes new. The Greek philosopher Heraclitus once said it's impossible to step in the same river twice. I mean, the outlines may be the same, but the water before is long gone. And so it is with our own bodies. Roughly 330 billion of your body's 30 to 40 trillion total cells are replaced every day. Now, of course, not all of your cells get replaced, but this means every 100 days, in total cell numbers at least, you regenerate a new you's worth of you. Are you the same you 100 days from now? Clearly, all of this cell regeneration must come with an equivalent amount of cell death. Otherwise, you'd be like a huge walking tumor blob or something. And this story of how your body manages its own death piece by piece gets interesting because different cells kick the bucket faster or slower than others, and some not at all. And a bunch of this cell death happens before you're even born. For instance, the cells that help grow the tiny bones in your middle ear, well, they did their job in the womb and died right before you were born. And after about 8 weeks of pregnancy, if your body didn't direct some very particular tissue to die at precisely the right time, you'd have webbed fingers today, which would make it easier to swim, but your ring collection would be completely obsolete. Broadly speaking, cells die in 2 ways. Cell death that's programmed by your body is called apoptosis, or apoptosis. It's Greek. The second P should be silent, but I know that feels weird, so however you want to say it is fine. Language evolves. Anyway, that's Greek for falling off. When the time comes for a cell to stop existing or it's broken beyond repair, it starts to shrink and form little blebs on its surface. That's really what they're called. DNA and cellular machinery are chopped up and carted off for recycling by your body's molecular salvage crew. And there's another kind of cell death if cells are, say, damaged beyond repair by toxins or environmental extremes. They basically just spill their guts. Cleaning that up is a bit messier, but your body's janitors are good at what they do. Think of your body like a car. You have to do maintenance to keep it running. If you couldn't ever get rid of old parts, instead of changing your oil, just kept pouring more in, you need new brake pads, stack them on top of the old ones. Pretty soon, luckily, that doesn't happen because you are dying inside right now in a carefully programmed and beautifully orchestrated way. So what part of you is dying the fastest? Well, you have around 200 different types of cells, all in all, acting as the building blocks for everything that you are, from bone to blood, intestines to eyeballs, and everything in between. On the most immortal end are your neurons. Networks of these cells hold your thoughts, your memories, your very consciousness. So obviously, killing and trying to replace neurons could really mess all that up. Neurons do make new connections and trim others as you learn or forget. But after your brain is done growing, you're pretty much stuck with the neurons you've got. This is why brain or spinal injuries are often so permanent. Interestingly, scientists have found that in one part of your brain, the hippocampus, neurons can regrow. This brain region is important in learning and memory, and about a third of it gets pruned and replaced throughout your life. And they prove this in a really amazing way. So massive amounts of radioactive carbon were released into the environment by nuclear bomb tests in the 1950s and 60s. And people alive during this time had radioactive carbon inside neurons in their hippocampus. The only way it could have gotten there is if they were making new neurons during their life in that little part of their brain. The majority of your body's bulk and mass is made up of fat and muscle cells, and these last for decades. Of all those muscle cells, the ones in your heart stick around the longest. To keep your blood pressure steady, keep feeding your brain enough oxygen, it's basically too risky to regenerate those. The cells that help build your bones, they last about 10 years. So a lot of your basic scaffolding and structural support, that sticks around a while. About 86% of the 30 trillion cells that you lose every few months are blood cells. Specifically red blood cells, whose only job is to carry oxygen from your lungs to your tissues and bring carbon dioxide back. These cells make up about half of your blood by volume, and they only last about 120 days. Some white blood cells, which only make up about 1% of your blood, they only last hours. 12% of your cellular recycling happens in your gut. Digestion is a dirty job. The cells that line your colon, for example, they last less than a week before being replaced. And then there's the stuff on the outside. You lose about 500 million skin cells a day, which means in a lifetime, you lose enough skin to cover about 1,000 bodies, which is pretty horrifying. So where does all of this dead you go? Well, everywhere. Every time you bathe, cough, sneeze, poop, spit, you're sending bits of dead you out into the world. All in all, about 2/3 of your body mass is made up of stuff that will at some point die and regenerate. Which brings up a couple interesting questions. If you fall in love with someone and maybe you spend decades of your life together, are they literally a different person than who you first met? And how much of you will never be alive in the first place? Let me explain that second question. See, almost 1/3 of your mass is stuff that's, well, it's not made of cells, it's made by cells. And so it's not really alive. For instance, the fluid outside of our cellular membranes, things like the plasma in your blood, tears, mucus, lymph, spinal fluid, the vitreous humor in your eyes, and even milk in some bodies. The liquid outside your pipes makes up about 25% of your mass. And another 7% is hard stuff like the calcium in our bones, the minerals in our teeth. Then you've got unliving stuff you carry with you, like the dead protein keratin that makes up your hair and fingernails. And you remember all those trillions of red blood cells you're constantly losing and making more of? Well, they have no nucleus. They have no mitochondria. They carry no genes. They can't make more of themselves. They don't metabolize. Are they actually even alive? Does that mean all of us have trillions of squishy zombie cells flowing through our veins, keeping us alive? That's the kind of thought, when you have it in the shower, can mess up your whole day. Or your connective tissue, things like ligaments, tendons, cartilage, they're actually made of these stretchy or spongy webs of protein and other molecules. Again, made by cells, but not made of cells. 3/4 of your connective tissue and all your joints and muscles is just this dead molecular scaffolding. All in all, a sizable fraction of what you probably consider you, the thinking, living being watching this video, is actually not alive. Of course, every person's body is unique, and all kinds of things can influence your cellular turnover and the number of living cells that you possess. I mean, a healthy liver has 240-ish billion cells in it, but a diseased liver could have as few as 172 billion. The person that belongs to, are they less alive than a healthy person or not? And some cancer cells are cancer because they've lost the genetic software that told them when to die. Is a person with cancer more alive? On a cellular level, the answer's less clear than you probably thought before you watched this. We can go even further. Much of the life that you carry within that quasi-living dermal sac that holds you together, it's not you. The human body is home to about as many bacteria and other microbes as it is human cells. As you digest and poop your way through your time on Earth, the balance of life within you shifts back and forth. We think of dead and alive as two sides of a coin, but it's more like a spectrum, a gradient. I mean, it has beginnings and ends, but any point between them is a mix of both. And maintaining the right balance of dying and regeneration turns out to be essential to health and complex life itself. I mean, in a way, we're a lot like that Shinto temple, aren't we? If your body had a philosophy, perhaps that would be it. Nothing can truly last as it is. Life is a balance of death and regeneration and rebuilding. Your body is a temple, blah, 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 blah. You get it. Anyway, the next time someone asks, "Who are you?" you've got a much more interesting answer to give them. Stay curious. Hey, have you checked out Out of Our Elements yet? It's a new PBS Terra series that explores the molecular stories underpinning our everyday natural world, from the first molecule in the universe to the water that we drink. Out of Our Elements shows that if you look closely enough, what may seem familiar can actually be kind of extraordinary. Check it out down the link in the description and be sure to tell them I sent you. As always, we'd like to thank everyone who supports the show on Patreon. And if you'd like to join them, we would really like your support. The today you, not the 100 days from now you, whatever cells that person's made of. But if future you would like to support the show too, you can sign up for an annual membership now. Just check out the link down in the description to learn more. Ooh, wait a second. Quick fact check. My muscle cells are particularly immortal. We're recording all this. I keep forgetting. Stop talking when you're the right to remain silent. Anything you say can will be used against you in the credits.